Hello everyone, my name is George Kobar. I'm a community advocate for Elastic's community team, and today I'll be talking about Observa-BLT. And this is a delicious practice that is more than just a tool for logs, metrics, and traces. While observability may be a new term to us, the computing or software industry, the term observability isn't new to the scientific community. In the control theory, observability is a measurement of how well internal states of a system can be inferred knowledge by its external outputs. I mean, that's the official definition. And we talk about observability, we kind of talk about these three pillars of observability that can kind of give us the internal state of our applications or infrastructure or data centers or our internal systems by the outputs of logs, metrics, and APM. Now, I'm here to tell you that while this is a great foundation, it's not the only thing that I think that makes observability work. At Elastic, we happen to call this Observa-BLT, and we'll kind of talk about this a little bit more in depth, but layering the bacon, lettuce, and tomato makes it for, in my opinion, an amazing sandwich. And we think, obviously, this foundational pieces of having these three in a unified platform or a unified view exemplifies that. And if you kind of look at this beautiful sandwich, or maybe this visualization here, we've kind of layered the logs, metrics, and tracing all within a singular view. And as a little later, when we kind of talk about the tool aspect of observability, I'll show you on how this can transform how you're observing your environment today. Now, if you look at the status quo today, a lot of this data, logs, metrics, and tracing data, happens to sit in many different silos. And what I mean by silos is that each team has their own tools. Like, let's say the operations team or infrastructure monitoring teams. They might have something for logging or metrics, and maybe the application team is looking at, the developers have their own tools and their own pieces to look at when they're troubleshooting performance problems, right? Or maybe there's an uptime, or there's a business tools for like SLIs or SIOs. But a lot of these tools could sit in different departments within an organization, and these aren't necessarily technical silos like network infrastructure or storage. These could be, personnel are also personnel silos. You have the network team, the application team, the development team, the operations team. Maybe you have DevOps as well. So a lot of these silos are obviously, have a lot of different tool creep, and a lot of different silos are not sharing information. And when it comes to an incident, obviously you'll have an increased time when we're trying to share data across to different systems. It's funny, me working with a network team or engineer, we always got blamed for the network. I mean, usually it is, right? Or maybe it's something with DNS. But, we'll say, well, our network's fine, jump over to the infrastructure team. Maybe it's the EC2 instances or something on Google Cloud, or maybe it happens to be something with CPU or memory, something with the metrics. Well, it's not that. We'll check with the application team. Each of these silos can also be identified as maybe fault domains. Every group that has a different responsibility, but sharing this information across the different silos just increases the amount of time for impact. Now, there's a lot of strategies for addressing outages, like let's involve the entire technical team on a call, or let's do a war room, right? So jump on a phone call. You are the 104th caller, and that just, for me personally, just sinks my heart. Like, oh man. Obviously it's a huge outage. It's all hands on deck to try to figure this issue. But there's a problem that I see with this, and having a unified view can really help with this. So with Elastic, we're focusing on really the unification at the deepest level for a lot of these problems. And what we think of that the deepest level is just the data, right? We're bringing all of this data into a single powerful data store, which happens to be Elasticsearch. So there's no pillars, just data. The unification at data of the level gives us the strongest angle to bring all these teams together. I'm not saying observability is just a bunch of tools or specifically a tool, because we know that's wrong, or hopefully you'll see that different strategies for different companies work. What I have to demo or what to show kind of gives you some other ideas on how to approach observability. But it's funny because when I think about this observability conversation, it reminds me of when we were talking about DevOps, right? For a lot of people that came to me and they said, oh, DevOps is just really a bunch of tools, which, of course, I hope you agree that's not the case, right? I mean, if you were to kind of group DevOps into these four main groups, it would say tools, process, people, and culture. And observability really could be framed in a very similar way. There's a lot of interesting parallels there. It could also be around tools, process, people, and culture. And of course, for a 15-minute talk, I won't really be going into a lot of depth into a lot of these, but I want to give you some helpful hints or something to research to see if you find also some commonalities there, or how you can help your organization. Now, of course, for tools, we'll skip for later. I'll go ahead and demo this at a later point, so you can kind of see from an Elastic's perspective what we're talking about unifying, or at the deepest level, providing the same data across multiple silos, or really breaking those silos down. So there's process, or specifically handling outages or incidents can be transformative, just like within the DevOps practice space. So there's been a lot of emerging discussions around the resiliency engineering that has interesting parallels with observability and learning what makes those systems resilient. So having data-driven decisions on what is not working or what is keeping the system resilient really helps the designing of these particular systems. You can also learn is the no root cause analysis. If you ever heard J. Paul Reed and some of his discussions, he's got a great talk on this at PublicConf. Basically, he gives the analogy of dominoes falling over, similar to what our linear thinking is for an issue. So we see the state of a domino chain if it doesn't complete. So we knock one domino over, but we see the final result of the dominoes not being knocked over. That's the end state, the actual problem. And that's very similar to how we see our applications. If we see a failure state, we typically only look at maybe the last resulting error or what happened there. Our linear thinking doesn't really show that there could be issues along the way that could impact the final end state. So there could be many points along the domino chain, but that doesn't throw an error that could still be contributed. And these are a lot of errors that we don't necessarily get surfaced. So these are the considerations that you have to kind of look through. By just removing one issue doesn't mean that you're actually removing the final result issue. And a lot of these complex systems are being built by sociotechnical systems or by people. And that kind of brings me to the next piece, right? The most complex piece of technology, a technology system, is the people, or is really the culture shift. Like the adoption of DevOps, a lot of organizations has to start with this culture shift. And a lot of organizations are really struggling with this, right? So studying some of the DevOps culture shifts and what other organizations have done has really helped organizations be transformative. And hopefully this can also cross the barrier for you being providing observability. So let's get back to the tools. So it wasn't too long ago that monitoring or troubleshooting outages resulted in these very similar views. I remember in my days on support running TCP dump on 2 different machines or doing a tail-f on messages, just hoping to find an error on why this system was down. And while this method of troubleshooting worked for monolithic apps, the industry is quickly moving away from this. How we develop and deploy and deliver software is constantly evolving. The continuous delivery model, migration to cloud, adopting a lot of cloud native principles like microservices, containers, or even the shift to serverless. These trends are all motivated by really similar reasons, which are reduce time to market or be more nimble to react to a dynamic market. And to add to the complexity of the fire, how do you troubleshoot issues when approximately 39% of the containers only live for less than a minute? This is according to SysDig 2019 Container Usage Report. How do we send all this ephemeral data to a syslog? By the way, this is me looking through a 7.78 gig log file looking for errors. Well, this is a search problem. And regardless if you have all this data in one centralized point like a syslog server or a data lake, or if all these logs happen to reside on the systems they come from, or if they're being uploaded to many different tools, it doesn't matter. This is still a search problem because you still have to search to why is your service having an outage, or why is your users having issues with your application performance problems, or what metric or what piece of data that I can use to be proactive. You're still searching for these problems regardless of where that's at. Elasticsearch is a search company. We're a search engine. If you bring all this data, this divergent pieces of data into Elasticsearch, you'll be able to get a unified view of all of these pieces of data. So this is just a quick example of kind of how we approach observability. I just want to take this brief opportunity to walk you through what Elastic considers to be observability from a technical perspective or from a tool perspective. And this scenario deals with, we received a report of a transaction that happened to fit outside of the normal that we see within the environment. And this is just an anomaly detection, and the transaction is a lot higher within our Advent service. And this variable could be, for example, a Slack message on how we get notified. It could be an email address. It doesn't matter on the actual action here, but we see, for example, on this email that the website is experiencing slower than usual response times. And one thing I could do is either select that message within Slack or directly within the email message. And it'll take me directly to Kobar, which is one of the ways that we're able to visualize this data. And right off the bat, I can see from our anomaly detection, from our machine learning, there are definitely some transactions that happen to be anomalous or a lot higher than what we expect. And if we actually select on some of these transactions here, it gives us more details about what's going on. For example, we see a high mean or something that's expected higher than it is for the duration. And if we actually go more into the details of the alert, we can see that the transaction is API owners. So we have a little more information about the owners. Now, having data that's coming from different systems like logs, metrics, tracing, APM data into Elasticsearch, and us being a search engine, we're able to search this data very quickly and provide a unified view to see all this data. One thing we can do is come look at actions, and we've got a lot of different choices about what could be going on with this transaction. We don't know if it's the infrastructure, if it's, for example, with the EC2 instance, or the Kubernetes pod, or the container, happens to be maybe with something within the application. At this point, we just got an alert, and we need to figure out what's going on. So we take a look at the APM analysis. We can take a look at the traces. And from here, we can see, yes, that we know that the API owners happens to be what was being impacted. And if we go into that APM tracing, we can see that the duration here, most of the transactions have a very little transaction time. But if we take a look at 3 requests that, for example, was at the longest in terms of the duration time, we can actually look through the traces here. Now, I'm not seeing any specific error messages here, so I don't think that's a specific issue with the calls that are being made, the tracing. So if I come back here, and I go back into the transaction of the API owners, let's go ahead and take a look at, let's say, for example, it's the pod metrics. So this is now going into the metric part instead of going through the traces. Let's take a look at what our metrics are showing. And so from the overview, we can kind of take a look at our CPU usage, memory, the network traffic, and a lot of other different services and connection points. But if we take a look at specifically the overview, we can actually just look at the metric overview here. And see here, we can look at, this is from the host perspective. We're seeing lots of high CPU usage over these particular hosts. But maybe we want to take a look at the Kubernetes, the pods there. What type of CPU are we using or seeing? Or maybe we want to look at maybe the CPU, or excuse me, the memory usage. And if you take a look at some of these higher pods, we see that there's not a lot of memory that's going on with the infrastructure. Maybe let's go ahead and take a look at the Docker view. And see, we can see a lot of the different components in the Docker pieces, and see if this particular CPU usage on this container is at 129%. Now, if I actually select on this, I can take a look at the logs or the specific view metrics from here. Let's take a look at logs and see if we can find anything specific. Here we can see the specific log messages that could be viewed here. One thing I'm going to do here is you can also hit live streaming. So this is equivalent to doing a tail-F, which gives you a lot of the ability to maybe jump on a live system and see exactly what's going on. So again, there's a lot of different viewpoints that a lot of different aspects of observability, those three pillars of logs, metrics, and APM tracing that you can look through an issue from a technical perspective. One last point, because I know I'm slightly over time. The observability solution that I demoed today was all built on our open source software, or the Elastic Stack, which was written by Elastic. So it's something that if you want to download and use as part of your observability practice, you could do so for free. Now, some of the parts of the demo, like the machine learning or the anomaly detection, that's part of our paid features, and it's something you want to investigate. You can go to elastic.co. Thanks so much for your time. I appreciate it. Thanks again.
Thank you, George.
Notice I shaved while I was off camera, so.
Nice. Yeah, I'm noticing a definite increase in the number of beards running around these days. Yeah, I think the lockdown orders have everyone just giving up on shaving. We've got time for a couple questions. We do have two queued up here. How do I incorporate customer-provided feedback, including app decks and customer surveys, with observability?
Yeah, so if you think about the Elastic Stack, basically we're just a search engine, and we're searching through like logs, or excuse me, any type of data, and that data is essentially just as documents. So, for example, if you're looking from like the BI analysis, if you're looking for, hey, if there's an incident, and then we see also an uptake on customer negative surveys or different calls, that's just another data source that you're bringing that data in. And what I mean by that is, you can have those logs, metrics, and open tracing data, but you also can ingest that data from, let's say, customer surveys, and that unified point could be based by time or by incident number, and that's just really another field within the document. So really what I'm saying is it doesn't matter on what type of data it is, because we're just searching that data. We're just basically providing the method on how you can correlate that data and bring that across. So hopefully that answers your question. But it's definitely very possible from a technical feasibility. It's just building the dashboards and everything else that brings that together.
Perfect, and we should have time for one more. In smaller teams with limited capacity, what's the most important parts of observability that people should focus on?
Yeah, so I think what the biggest, so because we're open source, one of the things that I like to tell people is to download it, use it, and just and try it. On smaller teams, I think what's critical is you're not jumping through different tools and different views and everything else, because if you understand one tool that can give you lots of different views, then you don't have to train yourself and integrate with multiple different areas. On a smaller team, I think, especially with the open source side, something you can use, consume, and gradually bring data in and kind of understand what the environment is. It's funny because there's a blog series that I was, or in a virtual meetup series doing for SMB businesses. There's not a lot of people from the SMB world that's really looking for new solutions, but it's something where if you use that and gaining knowledge of just the underlying environment can tell you much more about where, as a small team, you should focus on to make your life a lot easier. Reducing the amount of times on what you can take to resolve issues and free up more of your time to do other tasks.